All right, we're going to look at E and continuous compound interest. So the number E, think of it kind of like pi. You know how pi is a symbol and it is 3.14? E also is a number. Now it's not 3.14 because that's pi, but it's 2.7182, and it keeps on going. It's an irrational number. It keeps on going, just like pi. And here's a limit definition of what E is. All right, so the E is the limit as n goes to infinity of 1 plus 1 over n, and then raised to the n. Or can think of it as the limit as s goes to 0 for 1 plus s all to the 1 over s. I'm going to give you some formulas that you've probably seen over the years. I'll remind you. So simple interest looks like this. A for some amount is P for principal plus PRT. Or I could factor out a P and be left with 1 plus RT. Okay? Now you may have seen the interest formula as PRT, because that's going to be the interest on an amount. So having this formula here, adding in P is going to account for the total amount. Right, then we have compound interest. So you're going to have a final amount comprised of your initial amount plus, or times 1 plus r over n raised to the nt, where n is the number of times compounded, right? Or you have A for continuously compounded. A equals P e to the RT. Maybe I should write what all these letters mean over here. A is some final amount. P is a principal amount. Also seen it written like this, sorry. Principal amount. R is the rate, T is the time, N is number of times compounded. All right, so let's use some of these formulas. So what amount to the nearest cent will be in an account after 5 years if $100 is invested at an annual nominal rate of 8% compounded annually, semi-annually, and continuously? So let's do annually first. So that's going to give me an n equals 1. So I have an amount, that initial $100. My rate I need to use as a decimal. So instead of 8%, I'm going to use 0.08. N is 1, and the time is 5 years, right? So I'm going to plug this in, and so that doesn't look like a decimal, 1.5, I'm going to do this. 1 times 5. So we'll plug this in. So 1.08 raised to the 5th times 100 is going to give me, and it's to the nearest cent because we're in money, so it's going to give me 146.93. Let's do semi-annually. So it's going to be an n of 2. I always think semicircle. It's half a circle. So there's 2 pieces to make the whole circle. So semi-annually is going to happen twice a year. So we have the initial of 100. The rate is still the same. But this time we're compounded twice. And if I plug that in, the calculator, I get 148.02. And then continuously, That's the A equals PERT. So our initial of 100, and then times E to the RT. And so I get 149.18. All right. Let's try another one. If $5,000 is invested in a Union Savings Bank 4-year CD that earns 5.61% compounded continuously, graph the amount in the account as a function of time. Well, we can find it. Graph the amount for 4 years. So let's just evaluate that. So compounded continuously is PERT. So the initial amount was that 5,000. The rate as a decimal is 0.0561, and the time is 4 years. If I plug that in, I get $6,257.86. Right. Graphically, we're starting at 5,000. I'll just put 5K here, and we're growing. It's going to look something like this, right? What if it asked how much interest? It doesn't, but just what if? So how much interest was earned in those 4 years? So we can take the amount we had, so 6,257.86, subtract off the original amount we put in, and we're left with 1,257.86. That's how much we had earned in interest. All right, let's look at another one. So how long will it take an investment of $10,000 to grow to $15,000 if it's invested at 9% compounded continuously? So again, that's PERT formula. Let's plug in what we know. So we know in the end we want 15,000, and we started with an investment of 10,000. And the rate was 0.09, and then I want to solve for the time. So let's see if we can recall some of our algebra skills here. So I want to solve for the exponent, so I need to isolate as much as I can. So why don't I divide both sides by 10,000? And so 15,000 divided by 10,000 is 1.5. I'm just going to put that in one quantity, 0.09t. Now I want to get that out of the exponent. So what I can do is I can take the log of both sides. And now I'm going to choose the natural log because I have a base of e. Remember, natural log is a log with a base of e. So I'm going to take the natural log of both sides. So natural log of 1.5. I'm going to leave that because it is a decimal, so natural log of 1.5. That way when I plug it in the calculator, I'll just round at the end. So natural log and e. I can use my log rules and bring that exponent out front. So 0.09t times the natural log of e. Well, if you remember your log rules like this, right? If the base was the same as the number next to it, it was always 1, because the answer to a log is always what exponent is the base raised to get the answer. So in this case, natural log, the base is e, so e raised to what power gives out e, and that's going to be 1. So natural log and e, it's almost like they cancel out. They really reduce down to 1. So I'm left with natural log of 1.5 is 0.09t. And then I can divide both sides by that 0.09. And now this is what I'll plug in the calculator and round all at the end. So natural log of 1.5 divided by 0.09. That gives me 4.505, and decimal keeps going. So how about we round to 4.5 years? Let's do 4.5 years to take 10 grand and get it to 15. All right. How long will it take money to double if it's invested at 5% compounded continuously? So again, it's that PERT formula. And let's plug in what we know. I know my rate of 0.05. And then I want to find time, which means I know what my final amount and principal amount are. And to be honest, those actual numbers don't matter because it says we want the money to double. So no matter what, when we go to isolate this, we're going to divide both sides by that principal amount. And because of that money doubling, that ratio of final amount to principal is going to be 2. So it doesn't matter if you want to plug in some actual numbers, you can. Or we can say, hey, we know the ratio is going to be 2 because it's doubling. We can just go ahead and do this. And then it's the same steps as before. Take the natural log of both sides so that I can bring that exponent out. And the natural log in e, remember, is 1. And then I can divide both sides by that 0.05. And I'll just round the decimal, so 13.86 or 13.9 years. All right. Let's get a few more. You're considering 3 options for investing 10 grand. We got 7% compounded annually, 6% compounded monthly, and 5% compounded continuously. Which option will be best for investing for 8 years? And then how long would you need to invest your money for the third option to be the best? So that's a lot of questions there. All right, let's do compounded annually here. Annually. So we know we are investing 10,000. That's 1 plus this one's 7%. And we're doing it for 8 years. So 1.07 raised to the 8 times 10,000. So that gives me 17,181.86. Let's do the next one, monthly. So it's still that initial of 10,000. Our rate this time is 6%, but monthly, so that's 12 times a year for 8 years. So 0.06 divided by 12 plus 1 raised to the 12 times 8, which is 96, and then times that 10,000. So I get 16,141.43. Then let's do continuously. It's a different formula. That's PERT. This rate is 0.5. And this one, let's see, e to the 0.05 times 8 times 10,000 gives me 14,918.25. So which option is best for those 8 years given these situations? It's going to be the first one of annually. But it says, how long would you need to invest your money for that third option to be the best? Okay. So we would want to take the 10,000 e to the 0.05t. And we want to find out how long it's going to take for that third one to be the best option. Let's see what I want to put for my final amount. So you could look at it from a perspective of this was the biggest amount. So do we want to round way up and say 18,000 and solve for that time? And then it would be best. So like, oh, how long would you have to wait till you got more than 17,000? And we could solve that. So I will, but I want to do something else as well. So divide both sides by that 10,000. And that's going to be 1.8 e to the 0.05t, and the natural log of 1.8 is that 0.05t, divide by the 0.05, and I get 11.75. But I feel like if I plug 11.75 into the annual formula, right, so 10,000, 1 plus 0.07 raised to the 11, I could even do 1.75. I'm going to get 22,000. So I'm still going to get larger than that. So the other thing I want to do is just compare these growth rates. So if annually is the one that's growing faster, the growth is going to be this part here. So that 1.07 raised to that time value. I want to know, is it ever going to be equal to the growth factor of the continuous? So e to the 0.05t. So this will be when that they're equal, so we can know the time value of when it would be greater. So let's see, we can take the natural log of both sides. So natural log of 1.07, I'll bring the t out front. And then we'd have 0.05t, which is natural log of e, which is just 1. So we'd have t, natural log of 1.07 is that 0.05t. But if I try to get the t's on the same side, let's see what happens. So I will, just for easier sake, let's subtract the 0.05t over. And I'm running out of space here. Can factor out a t. I'm left with negative 0.05 plus natural log of 1.07 equals 0. I don't really care what quantity this is here, right? It's going to be some number. And to get t by itself, I would divide by that number, whatever it is. But 0 divided by some number is still going to be 0. So the only way these two are ever going to be equal is at time 0. So the third option is never going to be the best option, because that 1.07 is going to grow faster than e to the 0.05t. All right. So let's solve this next one here. I guess it's the last one here as well. So we can take the natural log of both sides. Natural log of e is 1. Bring out that exponent. Divide both sides by that 0.006. Natural log of 45 divided by 0.006 is 634.44. Didn't say what decimal to round to, so 2 is good. So, all right, that's kind of the basics of E and continuously compounded interest. So if you have any questions, let me know.